Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 1 for this week, and it's actually a makeup for Friday. You probably got word of my frustration at not being able to do certain things on the road that I think I should be able to do. And so we didn't get the bonus weather video out Friday, and so I'm doing it today. And of course, this was going to be the week I was going to change the 3 days we did the bonus videos to Tuesday, Wednesday, and Friday. We'll still do that this week. This is sort of an extra one today to make up for the one that we missed on Friday. So, and this video, before it's all said and done, is probably going to ruffle lots of feathers, at least across part of the segment of the people listening to this. I would just ask you to consider some of the things that I'm saying, and you can take what you like and leave the rest, I guess is the best way to put it. So let's go on ahead and I'll miniaturize myself here, and we want to take a look at the global satellite temperature record. Now, prior to 1978, prior to December of 1978, all we had was observations mainly over land, but we also had, weather balloon observations and some ship observations and buoys. But the thing is, the greatest density of observations was clearly over land, and the land only occupies about 25% of the planet. So we really didn't have a good way to look at the global temperature in real time and see how it's changing over a period of time. So with the advent of the satellite temperature record, we were able to do that, and so now we're taking a look at the entire globe, and you can see an awful lot of ups and downs here. These are monthly averages all the way from December of 78 up until August of 23. And what this shows is that the atmosphere has a lot of natural variability to it. Just because we started burning fossil fuels 150 years ago or whatever it was, didn't change the basic properties of the atmosphere, is that there's a great degree of natural variability, and the trick is to try to separate that out or take that out and see what you have left, and then that tells you what the human influence is in terms of this overall record. But clearly we do not have a stable climate in the sense that it's the same every year. It's different every year, and sometimes wildly different from one year to the next. Now, if you draw the straightest line you can through that mess, all right, that's called a linear trend line. And the slope of that line is 0.1364 degrees C per decade. And so over the course of 100 years, it would be 1.364 degrees C per decade. And if you change that into Fahrenheit, you multiply it by 1.8, and you would get something a little over 2 degrees Fahrenheit per decade if that trend continued at the same rate. But obviously, by doing so, you're missing out on a lot of details here. And so what I thought would be interesting to do, and this is something you can do in Microsoft Excel, is create what's called a sixth-order polynomial trend line. Now, the more terms you have in an equation, the closer you can get to approximating whatever curve you want to approximate. Now, it would probably take, well, it would take way more than 6 terms to be able to perfectly mimic all of these ups and downs that you see here, but this is closer to reality than the linear trend line, for sure. And notice what happens here. You have a period from 1978 up until, I don't know, about 1990 that's fairly quiet. In other words, it's not warming or cooling. And then you have a period where it increases, and then you have a period where it levels off, then you have a period where it increases again. And I know it shows a downward trend here at the end, but you got to be real careful with these trend lines at both the beginning and end of the record, because at the beginning, there's no data before this, and at the end, there's no data after that. And the only way you can assess what the trend is at that point is to have data both before and after that point. And obviously, at the beginning and the end, you're missing one of the two. So, but everything in between is perfectly legit, and you can see the stair-step nature to the temperature increase. So if somebody were to come up to you and say, like around 1990, global warming has stopped. No, it hasn't, okay? It's paused, all right? And in order to look at a climatic trend, you have to at least look at a period 30 years long. That's what the normals are based on, is a 30-year average, which is updated every 10 years, okay? But you can't look at a 1 year, a 5 year, or even a 10-year period and make any definitive statement about a long-term trend. Okay, so I have heard this theory put forth, and it makes an awful lot of sense to me, and I hope it makes some sense to you as well. But what I'm going to do here is start off with your basic sine wave, and I'm going to equate that to the natural ups and downs that we've always seen in the atmosphere. We see this with temperature, we see it with hurricanes. There's a very identifiable cycle there where you have inactive periods, active periods, and so forth. And for those of you that either never had trigonometry or have forgotten about it, an angle of 0 degrees, the sine is 0, okay? And then at 90 degrees, it's 1. At 180 degrees, it's back to 0. At 270, it's minus 1. And then at 360 degrees, you've gone full circle and it's back to 0. So this is what a sine wave looks like. Okay, now let's add in a linear function, and we're going to have that represent the steady increase in carbon dioxide as measured at Mauna Loa in Hawaii. Now that record goes back to, I believe, March of 1958. And it's darn near linear, as you'll see just in just a second. Not perfectly linear, but about as close to linear as you can be without being linear. And so going to have that orange line or tan line there represent the steady increase in CO2 that we've observed over, the last, well, in this case, back to 1958, but we know that it's been going on ever since the beginning of the Industrial Revolution. Okay, so there's the actual record from Mauna Loa going back to early 1958. And you can see that it's not a perfect straight line, but it's awfully, awfully close. And for all intents and purposes, you can call it a linear increase. Also notice that there are some ups and downs within each year, okay, which is a natural oscillatory cycle that this gas goes through. But the overall trend, as you can see, is up. So in March of 1958, 315.7 parts per million. In August of 23, which is the last month we have a complete data set for, 419.68. That represents a 32.9% increase since 1958, and it's estimated that it's been about a 50% increase since the beginning of the Industrial Revolution. So let's add these two functions together, okay? So remember, this is the sine wave, natural cycles. This is the linear function, the steady CO2 increase. You add those two together and you get a stair-step pattern where when both functions are going up, like they are here, then you add those two functions together and they're going to be going up too. Here in the middle, the sine wave's going down, the CO2 is going up, so they cancel. And then out in here, where the CO2 increases and the sine wave begins to increase, then you start to get an increase in the overall pattern. So if you look at this, rising, steady, rising. Now, let's go back and take a look at the actual temperature record. Steady, rising, look familiar? Okay. So it's very possible that what we're seeing here is an interaction between what the atmosphere would have done on its own without any help from human beings, and then adding the human influence to that, and so you end up getting this stair-step increase where it does pause periodically for maybe a period of 10 years, and then it starts to go back up again. So again, anybody that tells you that it's stopped, they're wrong. Anybody that tells you that every year is warmer than the one before that, they're wrong too, okay? So you have to be diligent about taking a look at this and trying to figure out what's natural and what is being added on to. So I'm going to make a few comments and suggestions here. Probably make some of you very, very mad, but the only thing I can ask you to do is to read and listen to these comments and suggestions respectfully. I will preface this by saying that I have become very disillusioned by the political division in this country right now. I've never seen anything like it in my lifetime, and I was alive during Vietnam, and it was pretty darn divided then. But it almost seems to me like we no longer have a two-party system, but we have a two-cult system. And it's, you're either on my team, or if you're on the other team, I hate you, and I want nothing to do with you. And we've lost the ability as a society to engage in constructive conversations with people of differing views. And the thing is, if you listen to those people that have the differing views, it's possible that you might learn something from that conversation. And the other thing is that you might find out that you were wrong about something, okay? Now, I know that's a perilous thought to a lot of people. We can't have that. But you think about it, Every time you're wrong about something, that means you've learned something, you've acquired knowledge, and you have advanced. Um, I can honestly tell you that probably the biggest lessons I've learned about weather forecasting have been from forecasts that didn't turn out the way I thought they would, okay? But then what you have to do is you have to care enough about the error to go back and study it, learn from it, so hopefully you don't make that same error again, okay? And that's, again, how we advance as individuals and advance as a society. So, number one, make sure the information that you're getting regarding climate change is actually coming from scientists. Now, this can be problematic for the following reason. And I know this is a gross generalization, but an awful lot of people would agree with me on that, including a lot of people in the scientific community are perfectly willing to admit this, that scientists by nature are introverts and are not the greatest communicators, okay? So that's a problem, right? If we want to get information directly from scientists and they sort of stick to themselves, and even when they don't, they're not the greatest communicators, then what are we left with? Well, by default, we're allowing loud, authoritative, knowledgeable sounding, and agenda-driven individuals to be our primary sources of information, which is not a terribly good idea in my humble opinion. So I will do my best to be your liaison to the scientific community. I've been very fortunate the last 10 to 15 years to meet a lot of the leading scientists in this arena and keep in touch with them on a regular basis. And so I keep up with what they're learning, what's going on. But I'm only one person, and I can only reach a very, very small percentage of people, okay? So it's got to be way more than yours truly on this if this is going to have any real effect. So I would ask you to be diligent in your research, have the willingness to be wrong. It's not a sin. It's nothing to be embarrassed about. And again, this is how we grow as individuals and collectively as a society. And remember, I used to go out and give a talk to civic groups and school groups, and the title of the talk was "The Scientific Method is Not Just for Scientists." Step one, you have a hypothesis, which is a fancy way of saying your opinion. And you're entitled to those. They're legal, okay? And you can have as many hypotheses as you want, okay? That's perfectly okay. Step two is to test the hypothesis. And here's where it gets sticky. The best way to test a hypothesis is to try to prove it wrong. Not right, but wrong. And only upon failing to do that do you accept your hypothesis as your conclusion. I think what we have now in a large part of our society is we skip from step one to step three, right from hypothesis to conclusion, because it's too much trouble to do the testing, and God forbid if we might find out we were wrong about something, okay? Again, if you find out you're wrong about something, that's not a bad thing. That means that you actually have more knowledge now than you did before, and I would think that that's where most of us would want to go in our life journey, if you will. So, that's it for now. That is bonus weather video number 1 for this week. Again, I would ask you to at least be respectful of these comments and suggestions. And you know what? If we all got together and instead of throwing rocks at each other and actually sat down and had a respectful and intelligent conversation, we might come up with all sorts of new ideas that would satisfy both groups' desires and hopes, okay? It doesn't necessarily have to be a mutually exclusive thing. You know, it can be at least a partial win-win if we have the desire to sit down and talk with people of differing opinions and be respectful of those opinions. All right, folks, that's it for now. Have a great Monday evening if you're still awake, and we'll talk to you again tomorrow. Take care.